in a chat on the platform you watch this stream, and I will answer them in the end of my presentation. We will have a Q&A session. So please send your messages, send your questions, and they will be discussed. So let's start with the presentation. We will touch three main things in it, and in the first, I will define how computers communicate between each other. So we will touch the low-level protocol of the communication to understand how computers send information between them. In the next part, we will discuss addressing of devices in a network. So how devices understand who is the source and who is the destination of the messages in a network. And in the end, I will describe the domain name system, the things which helps us to connect every day to our favorite internet resources. And let's start. So before we will discuss the low-level communication of the computer, the really important thing is to understand how computer stores data. The memory in the computer is divided into cells. So as you see in these pictures, here is 6 cells. In the cells can be something or there can be nothing, as in this image. So usually this something is an electron. So here is a black circle. So if in a cell is an electron, the value of the cell is 1. If there is nothing, it's 0. And like reading this memory, computer can understand that there is something or there is not. Each cell in computer memory has its own address. So like matched here, it's enumerated 1, 2, 3, 4, 5, 6. So to read some information from the cells, computer need to know the start address and the length. Actually, this kind of data called binary data, and one value, so one cell, is a 1 bit. So the bit is a kind of binary data where can be 1 or 0. So here we have 6 cells. So we have 6 bits of data, and each bit is enumerated. And as I said, computer only need to know the start address of the memory he need to read and the length of the data he need to read. So, for example, he need to read all 6 bits in his memory. He knows that the length is 6 and the address of the first cell is 1. He looks to this memory and one by one reads bits from it. So the maximum, so for example, let's imagine that we want to store a number in those cells. The maximum number we can store here is 64 because it's 2 to 6 power. And yeah, so the maximum number we can store here is 64. Actually, we can store not only numbers, we can store characters or something we wanna, strings, etc. and etc. The computer knows the protocol to like encode it and make the value he needs from it. So the main part, and so the brain and the heart of the computer is a CPU. CPU has a number of functions, and his main function as a brain of the computer is data processing. So he takes some data, do some operations with it, maybe like summary, multiply, or do something else, and stores it in his memory. So then computer controls the components of it. So he controls everything. He controls memory. He controls, for example, network interfaces. He controls graphic interfaces like video cards and etc. And to control everything, he use his pins. On the slide, you can see the image of the processor, and here is small gold circles on the top of it. So those circles can conduct electricity. So the computer can put some voltage on those pins or can disable the voltage on those pins. And that's how he can send some data to somewhere, to the one who connected to this pin. And actually, there is other modes for the processor to work. It's like input, so he can look to his pin and understand, is there any electricity or there is nothing. So let's move to computer networks, because that's why we are here. The computer network is two or more computers connected together somehow. And they can be one computer, and it's called standalone. But it's actually a network, and we will touch it in the future. So the computer actually is not only a PC, as it mentioned in the slide on the image. It's actually a phone, a laptop, it's a smart speaker, or anything else which has a CPU. Actually, your microwave or washer machine is a computer too. But we are discussing networks, and I think microwaves and washing machines are now not connected with the internet usually. So we will discuss computers like PCs, smartphones, laptops, and etc. So every computer has a CPU. And now we need to understand how does those CPU can understand each other. How can they communicate? For example, we want to send some data, 7 bits of data, as mentioned on the slide. How can we do it? We know that we can put some voltage to our pins or can disable voltage on it. And let's draw it as a timeline. Here we can see, so the upper state. So if the upper state is there is a voltage, and the down state, there is no voltage. So yeah, you can see this image, but how can the second CPU, the receiver, understand that he now need to read data? We need another line, or because actually, yeah, we can like decide that there is some fixed frequency with which CPU, the second CPU, need to read, but we can't really make it to work like the second CPU will read it in the time the first CPU puts data. So we need the second line of the communication, which is the clock line. So engineers called it like this. So this is a line with fixed frequency, and the second CPU reads that data from the data line every time the voltage on the clock line goes up. And okay, now we can send some amount of data from first CPU to second. But when the second CPU will understand that he needs to stop listening and process the data he received, here comes the data transfer protocols. So to make second CPU understand when to stop, we need firstly to tell him the length of the message he will receive from the first CPU. And so we put a length to our message. So first, for example, 8 bits will be a length. And the second CPU need to know that length will be 8 bits. So he receives 8 bits, translated to number, and then listens to other amounts of bits, which is data. And then, yeah, he receives the message and can process it. But there is another really important thing in those kind of communication, that we need to check the information. The receiver needs to check the information that he received, that it's okay, and he can work with it. And here comes the check info. So the goal is to understand the information is okay and how the check info works. It usually calls checksum. So the first CPU, when he creates the message, when he knows the data, he somehow calculates the number, or like usually it is 60 bits, 16 bits, which somehow calculates from the data, and then he sends it in the end of the message to the second CPU. The second CPU takes the data, calculates the checksum using the same function as the first CPU, and then the second CPU can check the equality and yeah, can check the equality and understand that data is good. He can use it. He can do the things he needs. Okay, now we have discussed how two CPUs, two computers, can communicate between each other, and they use data transfer protocol. But what if there is third computer? And let's imagine that their CPUs, each pin of their CPUs are connected to the other pin of the CPU of other computers. So, like for example, on the computer one, there is a CPU. He has a pin, a communication pin. It is connected to the pin of the computer number 2 and to the computer number 3. And the same for all three. So when the first computer sends some message, the second and the third receive it. And when the third sends some message, the first and the second receive it. So there is a problem because if first computer sends the message, both computers will receive them, but we actually don't want everyone to know what we are sending. So we need to identify computers somehow. We need to identify the source and the destination. And okay, we have only 3 computers. We can use numbers to identify them. So we now need to send our data. We now need to put some more information to our data. So we put a source ID and a destination ID. And we put this information into data of our data message. Because the source and the destination is the important information too, and we need to check it by the checksum too. So let's move further. And now we will discuss Internet Protocol addresses. But before I will tell about it, if you have some questions about the low level of computer communications, please ask them, write it to chat, and I will answer them in the end. Okay, so an IP address. It's a unique identifier assigned to each device in a network. And actually, we have done a network with 3 computers, and every device in it has its own identifier. But if there is more devices, like about like millions and or billions, like it is nowadays, we need using numbers is not really good because we have a lot of networks, and we will discuss it in future. So we need to use something else. And here comes an IPv4 protocol, IPv4 format of IP address. So it's 4 numbers which are separated by dots, and each number is from 0 to 255. So for example, the usual IP of router in a local network is 192.168.1.1. So an IPv4 can provide only 4.3 billion addresses. It's not too much. But because now we have a lot of devices, smart people decided that we need to have more. And they created IPv6. I actually can't explain you how it's like how it looks because there are not only digits, there will be not only digits, there is characters, and it's a long string of data. So we can identify everyone with a unique address. And actually, IPv6 can provide 340 undecillion of unique addresses. It's 10 to 24 power, as I remember. So routers, I have already mentioned them. And what is router? So router is a device that connects multiple devices into a network. In our previous example with three computers, there are three computers connected to each other. But in a real network, it's not really okay because we don't need everyone to know about everyone, and we don't need every computer analyze that it's message for him or it's message for everyone else. So people decided that, okay, we will use routers. Routers will make routes and send information to the source, from source to destination directly, not to everyone. So it's the first function of the router. The second, because everyone is connected to the router can give an address to every device in the network. And the other function of router is protecting network. So here comes firewalls. Firewalls can protect the network from someone who wants to crime somehow. And so if one computer in our networks won't connect to other, but we don't want him to do it, we can set up our router to stop such communications. So the network where computers are connected to one router called LAN, local access network, or local area network. Local area network is a network, for example, in your home, or a small business network, or in a school, or in a college. So somewhere where is not a lot of devices. And as I told you, a router provides IP address to assign this IP address to every device in the network. So, for example, we have three computers, and they are connected one by one to our router, and he gives them an IP addresses. So one is the second, third, and fourth. So we have discussed first type of network. It's local area network. And as I mentioned before, here is a personal area network. Fun. So personal area network is a network of your computer. Here will be only one device with one IP address. So actually, it's don't really understand why we need to use personal area network. But if there is some website running on your computer, you can access it by not using LAN. You can access it only using personal area network. So connect to yourself. It usually calls localhost. If you will try to put localhost in your browser, you will connect to yourself. There will be nothing because there is no website on your computer. But if there will be a website, you will connect to your own website, which runs on your PC. And then wide area network, one. So it's a worldwide and not only worldwide network. So it's a network with a large geographical area. Maybe it can be worldwide, it can be in one country, or it can be a banking network which banks use to provide the transactions. Actually, we can call the mobile network, which we use to call to each other. Usually, we can call them wide area networks. So, as I said, wide area network are really big. and there are a lot of devices. So if you will look to the internet, actually no one knows, but I think there is 10 or more billions of devices in the global network. I think more. So here comes an internet providers. So what does internet providers do? They connect everyone in a global network. So providers are connected to each other, and I will show how you in the next slide. So provider can be described as a router. He takes some data from other providers and from his clients and send it somewhere else. And actually provider can distribute data between his own network because it's a router. He has his own network too. And providers connect users. So because they are all connected to one network, they can send data from one part of the network to another using their connections. So here is a map of worldwide cables. This is optic fiber cables, which connects every provider in the world. They are going under Atlantic Ocean, and because they are optic fiber, they are really fast. So they send not electrons, as we discussed before, they use light, because light is much faster than electrons. And the data consistency actually rises while using light, not electrons. So let's look at the providers network. So here you can see those gray boxes, which are connected to each other by the optic fiber. So let's imagine the situation that we have a laptop and we want to connect some server. The server is connected to his own router. Our laptop is connected to our own router. And what do we need to know to connect to the server? At first, we need to know an IP address, because if there is no destination, how will we send the message to the server? So, okay, we have an IP address, but we need an IP address not of the server. We actually need an IP address of his own router. And as we can see here, the router has two IP addresses. First is a usual LAN IP address of the router, and the second is the global IP address. So the router, so if someone stays in a local network of a router, to communicate with this router, he uses the local IP address of a router. If someone from outer scope want to connect to router, he uses his global IP address. Actually, not every router connected to the provider has his own global IP address, because to have it, you need to pay some amount of money to your provider, not really big amount of money, and he will give you a static global IP address. So everyone will be able to connect to your router. But why do we need an IP address of a router, not of a server? Because the router has his firewall, and the router is the head of the network, of his local network. So if the owner of a server wants someone to connect to his server, he sets up the router to provide an access to his server. So the router knows if someone calls him from the internet, he needs to tell it to server, and he needs to send an answer back. So, okay, we connected to our server, send a message through the provider's network. And here is another part. But before we will start with it, I will ask you to ask me some questions, because it's really important. It's important actually for me to make you understand, not to answer the questions. So please don't be scared. Ask. So the domain name system. The domain name system is the things which helps us to connect to the internet, to our internet resources, our favorite internet resources. Yeah, to our favorite internet resources, not using their IP addresses, but using the domain names, human-friendly interface. So, for example, the domain name is www.example.com. And how domain name system works. So you enter a domain name, for example, youtube.com in your browser, and your browser sends a request to your router. Then your router sends requests to provider. Provider see that you want to ask youtube.com, and he looks who is youtube.com. So who in the network has this name? And somehow providers know who is it because they are DNS servers. So they have this information. They have a databases of the domain names. They find altogether an IP address of a server, and then you can connect your device to the server and watch your favorite video or something like that. So most popular domain names. For example, it's wikipedia.com, the most popular information source. Here is its IP address. I think if you will try to remember it, you will forget it in a second, but remembering wikipedia.com is not really hard for people. And then the video hosting, which you are using now, or maybe you are not using it now, but it's the most popular video hosting in the world, YouTube. It has his own IP address too. And the most popular search engine has its own IP too. And if you will look, an IP addresses of YouTube and Google are pretty close. Like first three numbers are the same. That's because here is IP address zones. So both YouTube server and Google server stays in one network because this is one company, the one data center. And here is the final thing that I will tell you about today is how does search engine or search engines work. So while we are typing something to Google, and he gives us the correct websites. So how he finds them? Actually, the first thing search engines do, they are crawling. They are going through the network, looking for every IP address, every server, every router, everyone, asking everyone, and trying to collect some data from them. So they downloads the web page, reads the information here, compress it, and put to their own database. And this calls indexing. So the third thing they do is updating this database. So they do it every time when you sleep, when you work, every time they are crawling and looking for some updates, updating their database. And the main thing, the most important thing, which makes internet really useful, is ranking. So they understand what website is more reliable for you, and they understand it by the information from the website and actually by the statistics of this website using. So it's actually all I wanted to tell you today. I hope you have enjoyed and you have understand how it works and that it's not really hard to do it. So let's begin with the questions I have received. Okay. Okay. So question number one, how does a VPN work? Is using a VPN safe? So how does the VPN work? Uh, Moderators, can I see my presentation, please? Thank you very much. So yeah, let's look to this picture. We have a laptop and we want to connect to a VPN server. Actually, VPN server is only a server. So as mentioned on this slide, this box with a CPU and a lot of memory, some other functions. So we send a message to the server. On the server, there is a special program which called VPN server. So he receives a message from us, and now he understands that we will send him some data, and he will need to send this data to the internet and receive an answer and send this answer back to us. So we just use it. So that's how it works. And the other important thing why VPN is so popular, it's encrypted. So all data that you send via internet is safe. So our server receives information from the server and encrypts it and sends it back to us. And that's how our provider can't understand that we are accessing the blocked website, bad website, because our server may stay somewhere where there is no blocking websites. So is using VPN safe? Actually, that's a good question, because if you use a VPN from some strange provider, he can access your data and he can store it. So you need to be careful with this and use VPN only from like really huge providers and which has license and something like this and has a security audit. So like using VPN is not so safe. So the second question, can I create my own domain name? Yeah, of course. You can create yours, but you can buy. So they're all domain names I already created. So you can just buy it from providers of the domain names. And they are cheap usually if it's not like x.com or something like that. So you just type, so to ensure that you can buy the domain name, you can just type it in your browser. And if it's for sale, you will see that you can buy, you will see a shop page. Or if there is no shop page, because some sellers of domain names not provide such things, you can just write to them that I want to buy this domain. So find some seller, type this, he will find who owns it, and he will sell it to you, buy it from the man who sell it, and sell it to you. So where is all the information from the internet stored? How much space is there on the internet? So the internet itself is not storing information. The information stores on the servers, like mentioned on this slide. They are everywhere in the world. A lot of servers are connected to providers. And so when you access some website with some information, you access a server where this information stored. So like, for example, youtube.com information stored on the server with an IP address I have mentioned on the slide about DNS. And how much information is there on the internet? No one knows, I think. maybe someone knows, but uh, we can try to imagine, but I don't think that we know such words if we will count it in bits. So the next question: what happens if somewhere in the woods has no internet and it needs to be conducted? Mm, okay, so you can actually use, yeah, we need to create a provider in those woods. So we need to take optic fiber cable and like take a car which can go to these woods, uh, put a server, a provider's router in those woods. So we will be connected to the internet. Question number 5: how mobile internet works when we don't connect to any Wi-Fi router? Yeah, so if we will, they're better to show a picture, but I will try to describe it without picture. So if your phone connects to uh, an operator, actually, your mobile operator is a provider. So while you connect to them, you just connect to a router too. So, and there is another thing how wireless connection works. So there is radio waves, which is which can be encrypted and which provides information. So the other question. I'm sorry because I haven't got a slide, so I can't tell it to you clearly, maybe. But you can watch a lot of videos. You can Google it, and that's actually the target of my presentation to make you try to find some information, try to make you be interested in it. So, how do you think was the future of the internet? This is the next question. The future of the internet, no one knows. So I think it will be grow. And now here is neural networks, which make internet access, which makes internet more useful because now we have like such things like ChatGPT, which accumulate all data from the internet and can give it to us fast and like explain it clearly. So I think internet will grow every time. So is it possible to be identified if you use VPN address taken from a special program? Mm, yeah, it's the question like, is it possible? In the internet, everything is possible. So, as I have explained, all these things are not really hard to understand. And on each level of an internet connection, you can be hacked, and the bad guys can take your information or like change it somehow, or steal your passport, go to your bank accounts, take all your money. So using VPNs is from bad providers, from any providers actually, makes you stay not in the best situation because everything is possible. And everything is possible more if you don't know how it works. And the last question, number 8, do you know how torrents works? So the torrents works like it's a decentralized network of servers, which are the same all over the world. So if someone downloads something from the internet and puts it to the torrent, to the server, to the server. So someone downloads a file to his not server to his laptop from an internet, and he sends it like he wants to share this file with others who use torrent. So he puts the file to the torrent, and so now everyone can download this file from his computer. So his computer is sharing the file with others. When someone other downloads this file to he stores this file on his computer and he shares this file too. So when the third person wants to download it, he downloads it from both computers. And the more this network is, the faster you download the file. This is what calls peers, the number of peers. So I hope my questions was good. Oh, there is another question. How do you think can any country create a sovereign internet? Yeah, they can. You can just cut those optic fiber cables and you will be disconnected. But do someone need to do it? Like actually, North Korea has a sovereign internet. It's not connected to the other world. They just have, as I know, their the government of North Korea has their own cables connected to the global network to Google something, I don't know, but the usual people are not connected to the global network. So creating a sovereign internet is an easy thing. But if you are already connected to the global internet, creating a sovereign internet is not a really like easy thing because all the websites running in your country, all the banks, all people use worldwide services, which sometimes are on the foreign service. So if you create a Syrian internet, you lost all this data. And actually, your internet will look like early 21st century interfaces. So it will be not beautiful as now, and not so fast, and not so encrypted and safe. So I think that's all. Here we can finish. Thank you for listening, everyone, and hope it will be useful for you and you will know something. You have find something new for you. Thank you.